So in the previous two examples, we looked at two different categorical variables separately, sex and classification. What if, however, we wanted to investigate how the classification breaks across sex? So here we're going to look at marginal and joint probability for two-way tables. Let's look at what's called a two-way table, sometimes called a two-way contingency table. It describes two categorical variables, in this case, sex and classification. So notice that in this particular example, we have totals across the margin, and these are called marginal frequencies. So notice what this table allows us to determine. What if I wanted to know how many juniors are male? We simply look at the junior column, and then we look at the male row and notice that there are 5 juniors who are male. We can also answer questions regarding the proportion or percent of certain categories or intersection of categories. This is often more revealing when there are different sample sizes. So for example, we could ask what proportion or percent of the class are composed of male juniors. So take the number of male juniors, 5, and divide it by the total number that are in the class, 73. So this gives us about 0.068 or 6.8%. So let's look at a distinction between these two questions. What proportion of the females are freshmen versus what proportion of the class are female freshmen? These are slightly different questions. In part A, we're only looking at the females. So we have a total of 12 female freshmen. We divide this by the number of females. So to get about 0.226. For part B, we are wanting to know the proportion of the entire class. So we divide this by the total in the class of 73 to get about 0.164. So I want to look at a few different ways we can display this two-way table in a graph. Here's a side-by-side bar chart. So you want to make sure you're able to see how this is read. Notice that the bar representing freshman, female, has a height of 12, which corresponds to the table. There are 19 female sophomores. So we look at the sophomore, look at the height of that bar, which is about at 19. And it corresponds to 19 female sophomores in the table. We can also switch the grouping variable around and look at the bar chart like this. In practice, we just want to select the chart that most effectively represents or communicates the data. So another display is called a segmented bar graph, as shown here on the left and right. So just to make sure you see how these two displays are related, let's look at the side-by-side bar chart and the segmented bar graph beside each other. So sometimes one graph will reveal something the other does not. For example, the segmented bar graph reveals there's a relatively high proportion of male seniors versus female seniors. So in the bar chart on the left, this doesn't jump out at us, at least doesn't jump out at me. The number of seniors between the males and females is about the same, but since there are fewer males, seniors take up a greater proportion. And we can see the same thing when we regroup it. So in practice, we'll only show one of these graphs. So you may encounter contingency tables that include row, column, or total percentages. For example, here are the percentages given for the total. Each percentage is found by dividing each entry by the total. So we can quickly see what the percent of female freshmen are by looking at this one table. Again, we take the cells and divide it by the total. So look and see how this checks out. We can take the female freshmen, 12 divided by the total, and we get the 16.44% that we got earlier. Now, if I'm just looking at one of those, I probably wouldn't create a table like this. But if I'm asked to look at several different variables this way, maybe I want to know the percentage of female freshmen and sophomore, maybe the percentage of male juniors and seniors, maybe I would create a table this way. Because that way I just create one table with the software, and it would generate all the percentages at once, and I wouldn't have to manually calculate those. So this next one is called a conditional distribution. This gives the row percent. So what that is we take each entry and divide it by the row total rather than the the final total of 73. So let's say we want to find the row percent for freshman females. We would divide the 12 divided by the row total of 53 and convert this to a percent, about 0.2264 or 22.64%. And here's one for the column percent. We know if we could be asked the question, what percent of freshmen were female? As we've been looked at before, we look at the freshman column, we take the 12 and we divide it by that total of number of freshmen to get 0.75 or 75%. Now we could include all the above in one table. So rather than having three separate tables, just be sure to pay close attention to the legend here. But this is a lot of information. It's usually best to look at these different percentages one at a time. Even people that are pretty good at coming up with these tables and deciphering them will generally do these one at a time rather than one table to cover all. So less is more in this case.